guys. This will be a very chill session. End of the day. Thank you for coming to learn about model fine tuning and what you can do with LLMs that are open source. Because we're kind of going to give you like a big crash course of what you can do when it comes to working with models to run them locally, right, as your own private AI solution, but then to start integrating your data into a model. Because with RAG, it's great to add the context from different data sources and do it dynamically. But there's some information that you should always have your model knowing, right? And you could put that in the prompt template, but the thing is, to go beyond that and to work with the model context size, things can get difficult. And so RAG can sometimes only get you so far. And we're going to talk today about how to kind of fine-tune a model and to get your data into that model so that every time you use it, it always understands certain concepts, information, and you can use it wherever it might be, on a Linux machine, Kubernetes, wherever your models run. You'll be able to use this open source project called InstructLab to do the fine-tuning from your laptop as a proof of concept. And with this, you're going to learn about LoRa. You're going to learn about adapters and open source LLMs. So, we ready?
Yeah, let's do it.
Cool. Just a quick introduction. My name is Cedric Clyburn. I make videos on the internet, which is fun, but previously kind of worked with container tooling at Red Hat, so you might have used Podman before, so I was working with those guys. Now do fine-tuning and kind of open source models with Legare here.
Yes. Hey, I'm Legare. I work with Cedric. We're both developer advocates on Red Hat's Artificial Intelligence business unit. Yeah, and we're excited to talk to you.
Yeah. And just poll, how many of us are developers here? Okay, everybody.
Wow.
Sweet. Cool. What's your expertise working with LLMs? Have you served your own models with Ollama? Have you set up like a RAG pipeline? Has anyone done fine-tuning before?
I tried. Just
cool.
You tried?
Nice.
Raspberry Pi, that's all.
Model on a Raspberry Pi?
I did the RAG, but I tried with the InstructLab, but it was hard work.
Okay.
Because I'm just exploring it.
Okay. Well, hopefully we'll provide some more clarity. I think someone else had their hand raised, what they've been doing with AI. No. MLX. Okay, nice. Mac users in the house. Okay, awesome. Cool. We're kind of going to integrate all of this, right? We're using InstructLab, which is underneath using MLX for some of the low-level model serving and fine-tuning. And then we'll hopefully answer your questions about InstructLab. This is a very casual session. You'll learn how to serve your own model. You're going to see quantized models, which is how you probably ran the model on your Raspberry Pi. And if you want to check out the slides here, we've got all this information, and we'll do the demos. And yeah, over to you, Legare.
Yeah. Okay, so we're going to start off talking about the power of open source AI. So we had the open source revolution, and then we saw cloud computing and automation, and now we're seeing open source in artificial intelligence and machine learning. Initially, we were seeing that models weren't necessarily on par with their open source alternatives, but we found that that has changed in the past few years. So we've all seen things like DeepSeek and Llama in the headlines, models that are open source that are really powerful and impressive. So we actually also use open source solutions at Red Hat. I think a lot of enterprises do things like take in their knowledge articles and help people find where company relevant information is, to generate snippets of knowledge articles. LLMs are really great at summarization, and then automated creation of standardized knowledge articles. So they're really good at generating text, right, as we all know. And so what are some of the advantages of open source models? Hey, Daniel. We can see that model cost is a lot cheaper with open source options, and you can customize them yourself. So we'll talk about how you can customize them via RAG, fine-tuning, and InstructLab, as well as security. So with InstructLab and other things like it, you can run things on your local development environment, which is going to provide you some more ability to sleep at night when it comes to your data security. And then as well as control.
Yeah, absolutely. So there's a lot of benefits, right, with using open source models, and I'm sure a lot of us have tried on our own machine. The thing is, open source models, and actually any model, say you're using ChatGPT or Gemini or any of these foundational models are foundational, right? They've been trained on, say, 15 or 100 trillion tokens of internet data, right? But the internet data isn't the data that you work with every day. And so we actually found that less than 1% of enterprise data is actually represented in these foundational models. And so for enterprises and organizations that want a model that can actually work with their data, understand it, and provide the best accuracy, you actually have to start from, say, for example, a trusted base model, one of these open source models out there that maybe you have more clarity on the training data and processes. Start from a representation of your data. So a lot of our data is in PDFs, it's in Concur, it's in Jira, Confluence. The thing is, models are used to working with Markdown, and they're used to working with JSON and standard text, right? So re-representing your data is a big part, and then deploying and fine-tuning a model with that data is the last step. So this is a kind of process that a lot of organizations go through, but your team probably doesn't have a lot of data scientists. And as developers in the room, we're not as familiar with all the PyTorch and Pandas and DeepSpeed and all these different libraries needed to fine-tune a model. And we shouldn't have to. But the thing is, in our own experiments doing fine-tuning, we've actually found that you can considerably lower your cost when it comes to a lot of different AI use cases, right? So question and answer over operating procedures, right? 96% cheaper than using a standard GPT-4 Turbo, right? It's because the model is way too oversized for the task at hand, right? Or analysis of customer call transcripts, right? Just processing a lot of maybe thousands of transcripts of calls for sentiment. Right, if you're doing your own model, you're using your own hardware, you can save on inference cost up to 94%. So there's a lot of advantages, not only in accuracy, but in price when we want to deploy these models and scale things up. But there's a couple challenges, right? From the cost that it is to, say, use third-party models in general, right, can be prohibitive for use cases. The complexity of not being a data scientist and not understanding these technologies, and the flexibility, right? You need to be able to deploy on the hybrid cloud, deploy where your applications are, and kind of talking to a third-party black box isn't always ideal when you're using AI. Right? And so we'll kind of go through this really quickly, but these challenges kind of stem from the cost, right? You're able to save up to 25% if you fine-tune your own model for a specific use case. To then the talent, right? A lot of us aren't looking for specifically researchers to join our team. We're looking for AI engineers, people who can work with LangChain, LangGraph, and MCP, and these agents, to then finally needing privacy and being able to control our workload, and that workload being AI. So.
Yeah. So how can we fine-tune, customize these models ourselves so that we can save that money? So there are a lot of options. You've probably all heard of these. We've got the basics of prompt engineering, just asking the right questions to a model. And then there's RAG, which is going to be taking temporal data from a source and bringing it into the model, but it's not going to actually change the underlying weights of the model, whereas fine-tuning will. So to talk a little bit about RAG, you can do a lot of things with RAG. You could pull in current weather sources into a model. You could pull information from like Instagram, anything current into the model, because we know that they don't always have up-to-date data, right? Because they're trained on data from the past. So that can be a really great use of RAG. And then one of the cons, though, is that it can be challenging to set up RAG efficiently, and the information that you add via RAG might not stay in the model for a long time because you haven't changed the model fundamentally. Whereas a pro of it is that there's going to be many off-the-shelf type tools to help you do RAG, and you don't need too much data science experience, but we're hoping that with InstructLab, you can kind of find that this is an off-the-shelf tool that you don't need as much data science experience, but you actually get to change the weights of the model and what the model is fundamentally. So what is fine-tuning? So as I just said, it's going to be changing those weights. With InstructLab, what we're targeting is smaller large language models, and we are adding in our own human-generated data, and Cedric's going to talk to you about synthetic data generation and how we can compile all of that data to then bring that into the model and fundamentally change what it is. And one pro here is that it's more accurate, and you can tailor the model performance, and it's not going to forget the things over time that you fine-tuned it on, right? But the cons is that it can be more complex. So is there another option? Yes. We're saying that that's InstructLab, and we're going to walk you through a demo of using it. And what's unique about it, as I mentioned, it's for smaller models, so 7 to 20 billion parameters, so that you can run it on your local development environment and not run into big issues. But you also won't run into like model collapse and things like that, which can be a problem if you're using other methods to fine-tune quantized models, smaller models.
Sweet. We're about 10 minutes in, so I figure we ask what you guys are doing. Some of you guys said you're already using RAG. Curious, has RAG met your expectations? Is it solving your problem?
No. Ooh.
It's, I mean, it does in 70% of the time, not all the time. So it doesn't answer, and especially the answers that it needs to read the whole context, like for example, the count of something. Right? That's very hard to actually grab it because the tokenization, the parsing, and especially if you don't know what is the content, then it's a dynamic content. So you cannot have a good parser for that or tokenizations of that. So it's a little bit tricky.
Okay. You said you're counting things?
Yeah,
what do you mean?
For example, we had an example here as well, here that there are speakers and then the count of the speakers. How many speakers are.
Oh, sorry. Thanks. No, appreciate it, bro.
Is it working?
I think so. Yeah.
How many speakers are in the, for example, conference?
Okay. Right.
So if you don't tokenize it very well, then you face a problem and it's not answering or it's answering wrong.
Okay.
So
like if you ask a model how many R's are in strawberry and it says 2.
Yeah, and also the embedding has a problem, right? So you have to have the embedding stuff, and so there are a lot of complexities in the basically reading the data, tokenizing it, put it in the vector databases, and then answering the right one. Yeah.
100%. Yeah. There's a lot of things here. I can hold that for you. That can kind of be like issues when you're doing a RAG pipeline, right? Whether it's the embedding model or the chunks or the vectorization and similarity search and the algorithm to pull the specific data, it gets very complex very quickly. And then, did you also have something?
Yeah, probably about the same point, but experience using RAG.
Yeah, love to hear. Thanks.
It really depends on the use case, I guess. For working with a big data, it could get very complicated, but RAGs are very, very nice if you're working with like a small piece of text or something. An example of that would be like a medical report. Like you already mentioned that these kind of models are good summarizing stuff.
Yeah.
So if you have like, I don't know, like a medical record or something like this could be actually a very nice way to use it.
Right.
But I'm excited about, fine tuning.
Yeah.
What could that bring to the table? So thanks.
Well, they're both, yeah, it's great you say that because they're both very complementary. Like it's not an either or situation. It's that, let's say you're working on some type of chatbot to work with medical records, right? But the model you choose, say for example, Qwen, right? Or let's say Meta's Llama 3.1, right? It was trained on Facebook data, right? So, there's not many medical conversations happening on Facebook as much as you would expect. And so it's like if it wasn't a part of the training data, how do you get that in there? And then pull dynamically the reports, right? So there are two ways to kind of plug in together that actually give you the best responses. And so we'll veer over to the kind of fine-tuning side because there's a lot of presentations about RAG and a lot of ways to do it, whether you're Python or Java developer. But for fine-tuning models, it's kind of a more low-level thing because traditionally a lot of data science teams or AI ML engineers would have to put together different tools. For example, pandas to say get all of your text documents and format that in a way to do like feature engineering, and then go from there to do data engineering and data cleansing, and then also kind of use like, for example, PyTorch and all these other libraries to do the fine-tuning process. And so the idea behind InstructLab is like to democratize this process. Because in the past, what we've done is we've democratized the science behind AI. So the Transformers paper is a popular example, like Google 2017, I think, released the paper, right? And it changed the fundamentals of AI. Because everything before was BERT, right? Like I can classify this as happy or sad, but I can't do natural language back and forth. And now this is the next step of allowing people who might not have data science expertise to be able to customize a model, right? So subject matter experts. And if anyone has a laptop, the demo we're going to do today, you can actually access this, and I'll keep it running for the whole day if you want to try it out. But you can actually access this lab from your device if you go to red.ht/devox InstructLab. So we've spun up some VMs. We've already pre-installed the CLI for you, so you don't have to have Python installed or anything. And so you can actually go through what we're doing today. And the password is devox. So I'll just quickly show that, and then we'll hop into the actual demo. Let me just make sure it works. Fingers crossed. Yeah, cool. So you just put your password, or put the password there, which is devox, and email is just to save your progress. So it's just a rel VM, and so you can check out how it works. The origin story is kind of based off this guy's dog. It's a Labrador, so that's why it's called the lab method for customizing LLMs. And what you're going to see here in a second is you start off with this taxonomy. So it's just a binary tree of different subjects and what you want to teach the model, right? The thing is, you probably have maybe 50, 100, 200 entries in there, right? If you want to train a large language model, you need thousands of entries, right? Thousands of data points, edge cases, right? So we're going to use a local LLM to generate synthetic data. And that synthetic data will then be evaluated by a critic model, a critic judge, and then train that back into the model using traditional supervised fine-tuning. So with that, shall we?
Yeah, let's do it.
Cool. So the process here is that we're going to start with some seed data. So this is kind of similar to any fine-tuning process. You start with your seed data you want to train. Let's say it's in PDF. We're going to convert it, create this question answer.yaml file, so it's in plain text, generate synthetic data, and then iterate from there. So any Java devs in the house? Awesome. Sweet. OK. Good thing I have this prepared. So what I want to show you as our use case today is kind of this Java application written in Quarkus. So we're using LangChain for J in order to connect to a model that's running locally. And what happened here is, we're evaluating, hey, what happened to this customer? Do they need help? This is Marty McFly.
We're an insurance company.
Yeah, insurance company. That's the kind of angle that we're taking today. And we can already kind of use AI to kind of summarize, right? So that's a big use case, is taking, say, this, this email and kind of, extracting the key details, customer sentiment. That's all good and well. But the thing is, we could use some type of model to help us evaluate and answer questions and make a decision faster, right? Because we've got a backlog of all these claims. So the thing is, let's go ahead and just serve a generic LLM. So I'm using the InstructLab CLI. So it's just iLab. So I did a pip install iLab, and I have that here. And I can kind of do a couple of main things, right? So I could, for example, download a model from Hugging Face. So I could get that quantized model, that compressed model. I could also serve it, so essentially create an endpoint, so a kind of an API for this LLM, so that we can make requests to it. And then also generate synthetic data. So if I do an iLab model serve, what we're going to do is serve this default model. So it's a derivative of Mistral. And it's running right now on our local host. So we can see that here we've got this API right here. I could ask, hey, what's the capital of France? Let's try it out. Fingers crossed. Paris, right? So pretty simple to just set up a kind of API for our model. And let's say, for example, you're using Olama, pretty much doing the same thing. But we want to chat with this model. So we could chat with it here. So we could do an iLab model chat. Or we could kind of just directly integrate it into our application, because right now it's being served on port 8000. So if we ask a question, go over here, what happened? And we're going to pull in the context from this specific situation. This could be done with prompt engineering, or it could be done with RAG. And so that's a pretty generic answer. The thing is, we want answers that are based off of our policies, right? Because this only gets us so far. This can only help us so much. But the model doesn't know the data about our organization, right?
Right. Which is common about a lot of enterprises, right? A lot of enterprise data isn't represented in models, which is why it's important to figure out how we can add it to models.
Exactly. So some of the information that we've modeled here, this is a question answer file. So essentially we're talking about, hey, this is the task that you're going to be trained on in the domain, and we have these questions that are related to, for example, our situation, right? Parasol claims, or for example, claim history, or policy, or the rental car policy, et cetera, et cetera. So what we're doing is we're using just a basic generic model. So let's ask this question that it wasn't trained on. So it's saying that the daily rental charge is incurred, say for example, 30 days, and that sounds pretty confident, right? The thing is, it's completely wrong, right? It's after the vehicle is undrivable, and so this doesn't really help us. So how do we put our model, train our model with this specific data? So I'll come over here, and actually we'll keep that model running. And what we're going to do is, since I've already got this data set up, so this is kind of representing how we want the intuition of the model to be. And we're also pointing to additional information. So a lot of us might have PDFs or this domain-specific data. Say, for example, it's in Markdown here. What's going to happen is, as we're running this local model, we're going to provide it with the question and answers, right, as a model of, hey, this is how you act. Then we're also going to bring in this source information so we can ground those synthetic answers in truth, right? Because if not, it's garbage in, garbage out type of thing, you know? So let's go ahead and test that out. We automatically convert PDFs, but I'll show you how to do that later, say, for example, for RAG or for fine-tuning. And I'll do an ILab data generate. And so what's going to happen here is we're going to query this local LLM that's running with this taxonomy. So all of the different contributions we want to give to the model. And what's happening here is that we're going and selecting this path, so the binary tree that I talked about, and we're creating brand new questions and answers, right? Say, for example, model, right? A lot of us hear model, we're going to think of an LLM. But the thing is, for this specific domain, that's not what it means at all, right? It talks about the vehicle's engine and all these other components. And so as this is creating new question and answers, and say, for example, if I had a GPU, it would kick off a lot faster, for example. But as this is being created, I can go over here and I'll stop it and I'll show you what's happening in the background, because this is all generated in JSON format. So what we just saw there is also represented now in this training data. So this is kind of a tabular form to take the source markdown and the source text and actually put this into a data set, and also be able to retrieve and reference the source content here. So it's a kind of way to ground the data in truth and create this data set that you could then use InstructLab, or maybe, like, for example, Unsloth or all of these other fine-tuning libraries to do a training process and then teach the model these new things. So in that case, what would happen here is I would do an ILab model train, and I would kick this off, and what would happen is we would download the full safe tensors from Hugging Face of our original model. So for example, if it's llama or if it's this Mistral derivative, and we would generate the adapter weights. So we're doing a quantized LoRa training. So essentially we're creating these adapter weights that will then plug into kind of one layer of the neural network, right? You could do a full fine-tune process, but that would take a day or two. This is kind of a quick way to get results fast as you're training a model. And what would happen here is we would essentially generate the new safe tensors, and we would generate a quantized version of the model. So a quantized version, you then run on your Raspberry Pi. The full safe tensors you would take and you could run on Kubernetes, right, with VLLM as a runtime. So we're going to skip that since I think the Wi-Fi is a little, you know. But what I actually have here is kind of the already cooking show magic created model. So we'll do iLab model serve, and in the path here, I already have the GUF, which is the quantized version of the model. And so we can actually start asking questions related to, what was the first question we asked? Yeah, maybe so rental car insurance. So we'll do a chat. And you're going to notice that this time we're actually talking to this trained model, right? So if we ask the question here, we actually get a real answer that is based on our true data, that every time we ask this model a question and we do a prompt, we're able to get this grounded answer back. And so then we can take this model that's running on localhost, or maybe we share it, we put it on Hugging Face, or we send to our developers or our team, and they can then use it in their application. So maybe, for example, we could say, what should we do based on our policies? Never works. Do based on our policies. And so hopefully, then we get an answer that's grounded in specific training data, for example. This one, I don't think we trained the actual model on what it should say in that situation, but now it knows for these specific things, like what is the car rental policy, then we can ask that question, and everything runs locally on this model that we have trained. So, yeah, not a bad kind of way to kind of get things started quickly on your local machine instead of having to download all these libraries. What InstructLab does is it puts together all of these tools. So, for example, document parsing. So I'll show this really quickly here as well. A lot of us have PDFs and websites that we'd like to use in our AI application. But the thing is, as I talked about before, models really only work with Markdown and JSON. So for example, we've got this PDF right here. So this is some annual report for a charity, right? And there's a lot of different elements here, and we want to use this to train a model, right? So it always knows about this. But for example, there's like tables and stuff. If we try to copy paste this or just do a basic beautiful soup kind of import, it won't really work. So what we're going to do here is use a tool called Dockling, which is included, for example, in InstructLab. And whenever you say, for example, source a PDF, so you point to a PDF here in this knowledge repository, well, it's going to do this automatically for you. So let me do a cat. Oh, sweet. So cool. It just parsed the whole thing. So it uses vision models to go through and be able to parse information like this that traditionally would be kind of difficult to pull from a document. But you can automate this and bring it into your RAG or your fine-tuning pipeline. So on that note, you've kind of seen how we use the taxonomy and how you can structure your data in this text format and synthetically create this data. So when you actually do the fine-tuning process, we do multiple stages, so you could teach your model skills. So for example, how to read this certain document, how to read this new format of text or of data, or you could teach it knowledge, like what we did with the insurance use case. And that's trained into multiple levels into the model. And yeah, you get this kind of end-to-end solution that you can own all of your data, and it's kind of brings together all these open source tools. And we did a POC with like a large telco in the US, and they were able to save pretty much 94% on doing large amounts of transcript analyzation. So it's a neat way to kind of do fine tuning. And as a developer, you don't have to be a data science expert. So on that note, yeah.
Thanks for coming, guys.
Yeah, thanks for coming. Happy to be here if you have any questions. And I know this is the last session, so appreciate it.
Yeah.